All right, let's get right into it. For decades, the world of AI has been playing one specific game, with one set of rules. But what if I told you the whistle just blew for halftime? We're about to step into a completely new era of AI, where everything we thought was important, well, it might not be anymore. And this one idea, this one quote right here, is the frame for everything we're about to break down. The idea that we're at AI's halftime. It kind of suggests that the first half was just the warm-up. The real game, the one with the real stakes, is only just beginning.
I mean, after seeing these incredible milestones like AlphaGo just dominating Go masters and GPT-4 acing the bar exam, it really feels like we've hit a new level, right? But here's the twist. That's not a peak, it's a pivot. The game is no longer just about building bigger and better models. No, the very rules are being rewritten as we speak.
So, to really understand where we're going, we first have to get a handle on the game we've been playing all this time. Let's call it the first half. And it was all about one thing: methods. Just think about the most legendary papers in AI history for a second. Papers like Transformer or AlexNet. What made them famous? It wasn't the specific problem they solved, not at all. It was the revolutionary new way they solved problems. Their contribution was a fundamental breakthrough in training, a new tool for the entire field to use. And I mean, this data really tells the whole story. The Transformer paper, it has over 160,000 citations. The benchmark it was tested on, WMT14, has about 1,300. That is a staggering difference, and it shows you exactly what the AI community valued: the method, not the problem it solved. And, this made perfect sense. Creating a new method, something like backpropagation or the transformer architecture, that was intellectually thrilling. It required this deep, profound insight. In contrast, defining tasks back then often just meant taking something humans already do, like translation, and just turning it into a benchmark. Plus, a truly great method was general. You could apply it to countless problems, which made it incredibly valuable. But then, something fundamental started to shift. The culmination of all these breakthroughs from the first half led to something totally new: a reliable, almost standardized process for solving really complex tasks. A working recipe, if you will.
And these are the ingredients that changed everything. First, you start with massive language pre-training to build this huge foundation of knowledge. Then you add just incredible scale, both in data and compute. And the final step, you give these models the ability to reason and to act. You put all of that together, and the result is just unbelievably powerful. Now, to see how this recipe really came together, we need to understand a quick concept from reinforcement learning, or RL. Just think of it as having three key parts. You've got the algorithm, which is how the agent learns; the environment, that's the world it plays in; and the priors, which is the knowledge it starts out with.
Okay, so this whole thing unfolded like a detective story. For decades, researchers were just obsessed over algorithms. Then, during the deep RL era, they realized, hey, the environment is actually crucial. But the real twist, the thing that nobody saw coming, was the GPT-3 shift. The missing piece for powerful general RL, it was the priors. And this is just the sarcastic part of the whole story. Researchers spent decades perfecting these RL algorithms, only to discover that the most critical ingredient was massive language pre-training, something developed completely outside the field of RL. It turned out you needed to distill the world's knowledge into the model before you even started the whole RL process. The final, almost magical ingredient was adding thinking as a possible action. So instead of just choosing to open a door, the agent could choose to think about how to open the door. Now, this seems totally counterintuitive in classical RL. It adds infinite, seemingly useless actions. But what it does is it allows the agent to tap into its powerful pre-trained knowledge to generalize and solve problems in a way we've just never seen before. So, with this powerful new recipe in hand, the entire game board changes. And this brings us to the second half, which is no longer a game of methods, but a game of problems. So just to recap, the old game was simple. The playbook was you developed a new method, and then you used it to get a higher score on an existing benchmark. That was the loop, over and over. But the new game is completely different. Now, the real challenge is to define novel evaluation setups that actually measure real-world usefulness. Then you apply the recipe to solve them. See the shift? The focus has moved from how you solve it to what you're solving, and more importantly, why. And this brings us to the most important challenge for AI today, what's being called the utility problem. We have AIs that can be world champions, that can score perfectly on standardized tests, but we haven't seen a corresponding revolution in economic productivity. So, the billion-dollar question is, why?
Well, the root cause might be that our old ways of testing are built on flawed assumptions. They assume a task is autonomous, one prompt, one answer. But real work is interactive, it's a back and forth. They also assume tasks are independent, or IID, meaning each task is a totally fresh start. But a real software engineer, for example, gets better at their job over time by building familiarity, and that's something our benchmarks don't capture at all.
So how do you win in this new game? It's not about being a better coder or a more brilliant algorithm designer anymore. It's really about a fundamental shift in mindset.
The first half was played by researchers asking, how can we solve X? The second half, though, is going to be dominated by people with a product manager's mindset. People asking, what should we be solving? And how will we even know if we're making a useful difference?
And that's really the ultimate takeaway here. The race for pure intelligence, for just getting a higher score on a benchmark, that race is over. The recipe we have now is incredibly intelligent. The new frontier, the grand challenge of this second half, is to channel all that intelligence into tangible, real-world utility.
So we're left with this question. The tools are here. The recipe works. The challenge is no longer just about building a better hammer. It's about figuring out what's truly worth building in the first place. So what problems will you define?